The battlefield is changing. A soldier once needed to see the target. An artillery battery needed coordinates. An artifact needed to fly deep into hostile territory. Today, a relatively small unmanned aerial vehicle can search the battlefield, identify a target, and deliver a precision guided weapon. The weapon may be smaller, the platform may be cheaper, but the effect can be enormous. This is the new age of asymmetric warfare. And India's ULPGM-V3 is a fascinating example of how this transformation is taking place. Let's start with a simple battlefield. Imagine two armies. One possesses expensive fighter aircraft, large armored formations, and sophisticated weapons. The other cannot match that conventional military power. So instead of fighting the opponent where it is strongest, it searches for a cheaper, smarter way to create an advantage. That is the essence of asymmetric warfare. The weaker side, or sometimes simply the side seeking greater efficiency, uses technology, mobility, information, drones, cyber capabilities, or precision weapons to challenge a stronger opponent. And drones have changed this equation dramatically. Now imagine a drone flying above the battlefield. It doesn't need to carry a massive bomb, it carries a precision guided munition. Instead of destroying an entire area in the hope that the target is somewhere inside it, the objective is to put the weapon much closer to the intended target. That is the fundamental idea behind precision guided warfare, accuracy over volume. This is where India's unmanned aerial vehicle launched precision guided missile V3, short for ULPGM-V3, enters the story. In May 2026, DRDO completed the final development trials of ULPGM-V3 at its test range near Kurnool, Andhra Pradesh. The trials demonstrated the system in both air to ground and air to air modes. The missile was integrated onto indigenous unmanned aerial vehicles developed by New Space Research and Technologies under DRDO. That immediately tells us something important. This is not simply about developing another missile, it is about creating a drone weapon combination. The drone becomes the eyes and the launch platform. The missile becomes the precision effect. Together, they create a new layer of battlefield capability. And ULPGM V3 is more versatile than its earlier versions. The V3 incorporates an advanced seeker and a two-way data link, allowing operators to update the target or aim point after launch. It can also operate against both ground and aerial targets, including drones and helicopters, according to DRDO limited reporting. Think of the difference between throwing a stone and throwing a smart ball that can continuously receive instructions about where it needs to go. That is the conceptual leap created by networked precision weapons. The missile also has modular warhead options for different battlefield requirements. One option is designed for anti armor roles, another is intended for penetration and blast effects against fortified structures. A third provides fragmentation effects. So, one weapon system can potentially be configured for different operational requirements rather than relying on completely separate weapon families. But here is where the story becomes bigger than one missile: indigenization. DRDO says ULPGM V3 has been developed through an Indian defense ecosystem involving multiple DRDO laboratories and Indian industry. For production, DRDO has partnered with Bharat Dynamics Limited and Adani Defence and Aerospace, while the unmanned aerial vehicle used in the trials was developed by New Space Research and Technologies. This is important because modern military capability is not created by one laboratory working alone. It requires research, design, testing, industry, production, armed forces. That entire chain must become strong. And that is where strategic autonomy enters the picture. Imagine India depends entirely on foreign suppliers for critical precision weapons. During peace, everything looks fine. But during a geopolitical crisis, what if spare parts are delayed? What if exports are restricted? What if technology access is denied? Defense indigenization reduces such vulnerabilities. It does not mean producing every component domestically overnight. It means progressively building the technological and industrial capacity to design, manufacture, upgrade, and sustain critical defense systems within India. ULPGM-V3 is therefore significant not merely because a missile flew successfully. It demonstrates the growing ability of India's defense ecosystem to develop and produce advanced unmanned precision weapons domestically. So remember the larger picture. Asymmetric warfare asks how can technology offset conventional disadvantages? Precision guided munitions ask how can targets be engaged with greater accuracy and reduce dependence on sheer firepower? Unmanned systems ask can dangerous or persistent missions be performed without putting a human pilot directly into the platform? And indigenization asks can India control the critical technologies needed to sustain its defense capabilities? ULPGM V3 sits at the intersection of all these four. So the next time you hear DRDO successfully tested ULPGM V3, don't remember it merely as another missile test. Remember the larger transformation. The battlefield is becoming increasingly unmanned, networked, and precision oriented. And India's strategic challenge is no longer simply to possess weapons. It is to build an ecosystem capable of continuously designing, testing, producing, and upgrading the technologies that future warfare will demand. That is the real story behind ULPGM V3, not just a missile, but a glimpse of India's evolving approach to asymmetric and precision warfare.